Welcome back. That last panel discussion on additive metals pretty much gives a great segue into my next vignette. Native Daytonian and electrical engineer Pierce Schenck founded Duriron's casting company in 1912. Following much experimentation, Schenck developed a high silicon iron alloy that was the most durable iron material ever made. Duriron Castings Company, now called Flowserve, specialized in the containment of acids for munitions production during World War I. By the 1920s, the company produced a complete line of pipes and fittings for acid waste disposal, along with high silicon iron pumps and valves to handle chemical solutions. Stainless steel products were in production by the end of the decade. Daytonian James Parsons Jr. started working at Duriron in 1922. He later became the director of the Duriron Research Laboratory, supervising what was reported to be the nation's first only all-black laboratory staff. He received 8 patents vital to advancements in the corrosion resistance and production of stainless steels. 2 of his patents resulted into the 1939 introduction of Duramet 20, a high alloy stainless steel with excellent corrosion resistance. One of its many uses included the special materials used in the handling of the radioactive components for the Manhattan Project during World War II. Well, I think Pierce Schenck and James Parsons were pretty smart individuals. So now let's hear from these smart guys on some smart logistics.
Thanks for the setup, putting me in the ranks of being smart. I don't know that that really goes. Good morning, everybody. I'm Carl Schaffner. Probably many of you already know me. I'm Schaff. I apologize that you're looking at my back over here, but I want to be able to look at my panelists. Really appreciate the opportunity to bring this panel in front of you. The whole the business of smart. Whether it be logistics, which is what we're really focusing on today, and obviously you're going to hear from these gentlemen the real value of bringing smart technologies to logistics, how it can be a game changer. I want to put in a plug for Jeff's 6 comments. Jeff is in the room. Can't tell whether Jeff's in the room. I definitely want you to make sure you come around to hear Jeff's presentation this afternoon, because I think he's going to talk a little bit more smart logistics and specific some of the things that they're doing in AFSC. So make sure you hang around for that. Make sure you hang around for all of the discussions this afternoon. Having been a former panel member, I know what it's like to be the last person on the last day. And in fact, down in San Antonio one time, I was the last speaker. And if it wasn't for my friends, I wouldn't have had anybody in the audience. So I really want to encourage you to stay around. There's some great content this afternoon with some of the presentations that we have. So please try to hang around for all of those. And the last plug I'll put out there is maybe smart is not the best term to be using when we start talking about the technologies and the capabilities that these gentlemen are going to relate to you. You know, obviously it has much more to do with broader concepts of IoT, and maybe smart's not the right word. I'll let those guys kind of comment on that as we go. So with that, I'm going to let each of them take a few minutes to introduce themselves and a couple of opening comments. I've got Slido sitting here on my lap right now, so if you have questions for them, please go ahead and send it to them. And I've already got some stumpers lined up for them. So with that, Chad, why don't you take the lead?
Thank you, Shaw. Good morning, everyone. Chad Jones with KPMG. I lead our global government supply chain and procurement practice, but also responsible for our federal practice in supply chain and operations. This gives me the ability to work across all the portfolios of civilian, intel, DoD, in all aspects of digital supply chain. And as Shaw said a few minutes ago, look forward for the next 50 minutes or so to talk about smart. We're doing one of the first installations of the 5G smart warehouse with the Marine Corps. And it's more than just smart. It's how we're taking digital, it's how we're taking process, and as importantly, how we're integrating the material handlers and supply techs into this process. It's absolutely critical of the human element or the human in the loop portion of this process itself. I have responsibility for multiple different areas, agencies, Marine Corps, Air Force, DLA, across the civilian with some of the health agencies that we started doing work with this year. So look forward to talking to you about that. So whatever questions you may have as we go through this, absolutely look forward to it. Thank you for joining.
Thanks, Chad. Appreciate it. Dale?
All right, well, good morning, everybody. I'm Dale Tutt. I'm the Vice President of Industry Strategy at Siemens Digital Industry Software. And what that means is, we have a very broad product portfolio. We're a global company. We have a lot of solutions for our customers. And so my team focuses on where do we need to invest, where do we need to develop solutions for for our customers in a specific industry. I joined Siemens about 3 years ago as the Vice President of Aerospace and Defense Industry. Prior to that, I had been in the industry for about 30 years. And we always like to hire people from the industry for this role so that we're bringing, I kind of always joke, we're bringing the voice of the customer into the company. So before I joined Siemens, I was most recently at Virgin Galactic and the spaceship company. I was leading the engineering and program management teams out there for quite a while doing commercial space tourism. Got the team to space in 2018. It was very much an R&D prototyping environment. Before that, I was at Cessna for a long time. And at Cessna, I was in a lot of different engineering and program management and manufacturing type roles. I had been the chief engineer and program director for the Textron Airlines Scorpion Jet, where we developed an airplane from a concept sketch to first flight in 18 months. But then at the other end of the spectrum, I was also the director of engineering for the T6 program, where we were in sustainment already. So we'd work with the AETC on how do we keep the airplanes flying. And so I've seen kind of this full spectrum of these life cycles and how digital transformation can influence them. So at Siemens, we're heavily involved in digital transformation for our customers. We have the Accelerator portfolio, which really supports customers and their programs throughout the entire product development life cycle. We talk a lot about, one of the things that we talk about as part of that portfolio is what we call the digital thread for defense. It really kind of focuses on 3 areas. One is around how do you accelerate our acquisition process. Second is how do you deliver product faster, those capabilities faster. And then finally, the third gets into that, how do you maintain them better? And so I don't know if smart logistics is the right answer. When I was in the industry, sometimes we get caught up in names, but the reality is what's the outcome that's desired? And the outcome is how do you improve the operation availability of the products, the systems? How do you keep them flying? How do you do it faster? How do you do it at less cost? And so if that's the outcome from smart logistics, I think digital transformation is key for that. So thank you.
Appreciate it, Dale. Troy?
Yeah, good morning. My name is Troy Edgar. I'm a partner at IBM Consulting. I lead the Federal Finance and Supply Chain Transformation practice. I'm very honored to be here, and I just wanted to thank everybody that's here today that supports the Air Force. Thank you for your service. We really appreciate it. I'm a U.S. Navy veteran, and I ended up kind of coming to this where I've kind of touched this world early on in my career. I got out of the Navy as a submariner, so I actually dealt with this type of issue as out at sea and in the shipyards. And then once I got out of the service, I ended up going to Boeing, McDonnell Douglas, and started in manufacturing, worked my way into logistics, and then got involved with the C-17 and the base activation at Charleston Air Force Base way back in the day, if that kind of gives you an idea. After probably 10 years in the industry, and I left as the CFO for the logistics business, I ended up going into consulting at PricewaterhouseCoopers, led the finance and supply chain practice there, and then I've done a lot. 2018, outside of doing what we do for a living, all of us in here, I'm active doing public service, and I got a call to see if I would be interested to become the chief financial officer for DHS as a political. And specifically, I'm a business guy, not so much political, but I was really brought in to, while there was a lot of drama going on in DHS, there was a lot of operational issues going on in DHS too, specifically around supply chain and operational readiness. So I ended up coming in, really focused on working with the Commandant, mission support systems within the Coast Guard, financial systems modernization, and some of the stuff that I would normally do in consulting. you know, it ended up, after I got out, I went to IBM, and that's how I ended up here. But I would just say that today is going to be a great discussion. The smart logistics as a topic is something that, from an IBM consulting perspective, that we're very focused on. You know, that career path that I talked about, the 20 years between Boeing and coming back into the federal government, I spent that in the Fortune 500, doing a lot of work for Toyota, a lot of different manufacturing, automotive, and industrial products. And so I think that it seems like we're a little bit behind in what we're doing here to try to get kind of caught up. And so I think where IBM Consulting has really been able to kind of get into this is we're really bringing our knowledge of smart logistics into this. You know, we're a Fortune 38 company. We did this to ourselves too 10 years ago. We've been finishing that journey. We've been doing it in the commercial side. And my job, very similar to my colleagues, is I'm responsible across the portfolio. So I focus not only in DoD, but everywhere. And I just see a tremendous opportunity. I look forward to this discussion and Shaf, all the topics that we talk about. Thank you.
Thanks, Troy. And last, but certainly not least, John, I'm going to let you do the introduction, but I'm also going to go ahead and tee up a question, and I'll let you address it, and then we'll work our way back down the panel. But the question is, so we're kind of talking up here a little bit strategically in terms of smart logistics, and it sounds good. Tell us some specific examples, and Dale, you even said something about delivering digital solutions. So maybe give us some examples of smart logistics and the tangible benefits. But first you get to introduce yourself, and then you have to answer the question.
Yeah, so hi everyone, I'm John Villegas from Sable Systems. Sable's a small business technology solutions provider, really working in digital engineering, CAD, PLM, IoT. But I have experience doing PLM solutions, all that. I was brought in about 2 years ago to kind of help the Marine Corps adopt PLM to support logistics and acquisition and really additive manufacturing, how that can really support LogCom. So I guess that's kind of good enough for a quick intro to get into that. The question of kind of solutions in logistics, kind of we were talking earlier, the additive panel talked about how additive manufacturing really is a logistics solution. So we're really kind of working to see how additive manufacturing can come in to support the logistical supply chain, get kind of some of those manufacturing bits closer to the source, kind of support those vehicle systems out there, especially as things are being phased out, acquisition rights becoming more of a topic. How can additive kind of support that digital thread in kind of Marine Corps and logistics? As a quick answer, I guess.
Troy?
Yeah, so I think for my example, I would use industrial IoT. You know, what we're seeing at IBM right now is just a really significant focus in getting the data from plant equipment and warehousing equipment into operating technologies and up into analytics. And obviously the IBM play within analytics and AI and to do augmented activity there is really important, but those analytics really help for better decision making. And you know, what we see within the IoT space, and I'm sure we'll talk about this in some of the questions, is some of the challenges in that whole process. I was listening yesterday, a lot of discussions on data, and you know, but this is data in a different realm. This is you know, a lot of times we buy machines today in different services, and they actually create a ton of data. We just don't use it, or we create it, we don't understand it, and then you put a supercharger on analytics on IoT, and you try to become quote smart logistics. It becomes even. It can be helpful or it can be a weapon. So we'll talk a little bit about that later. But yeah, industrial IoT.
Sure.
Yeah, so I think when we think about the benefits that companies and customers can get from from these capabilities, there's a couple elements that we need to think about what it takes to actually get there. And one is having a good digital twin, an understanding of your product or system or the processes that you're using to manufacture and maintain it. You need a good PLM foundation, and you also need IoT and the data analytics that can come with that. And once you have those things together, you're able to now start to really make good decisions. You have the data analytics and you have the basis for really understanding that data in the context of that system or production process. So Rolls-Royce, one of our customers, they were looking how do they improve the serviceability of their engines, their products that they're making. They're involved in engines, but they're also involved in like nuclear reactors. And they're doing energy generation. So a lot of different areas, but they were looking at how do they improve the development of their products as well as how they're servicing out in the field. And so They've been on their digital journey for a lot of years. They've been working on digital twin. They then implemented IoT and MindSphere and our data analytics, and they really have closed the loop on that digital twin now. And some people say, hey, well, that's a bit of a unicorn. You're actually going to have a closed loop digital twin. And yet they've been able to implement this now. And the results, they're getting a couple of results, and probably, when I hear the case study, not the things that are most obvious to me, but they're able to improve the performance of their engines as they're operating out in the field. But they're also using it to learn how those engines are operating, and then using that information to feed back into their manufacturing process to improve their manufacturing process. And then finally, they're using that to improve the maintainability, the maintenance cycles for the engine, where they can benefit from the different reliability numbers. So they're actually able seeing benefit across the board by implementing really the full cross-section of digital transformation and smart logistics.
Thanks, appreciate that.
Hey, I'll give you a specific example. So we were asked to go perform a proof of concept for this digital warehousing in the largest armory in the Marine Corps. This armory covers weapons, optics, and ComSec gear. As you can imagine, as probably many of you have worked in, there was the 4 green logbooks. There was everyone writing everything down from document in and serial number, highlighting and so forth through this process. So our goal was to create a fully digitized warehouse. So not only did we put in a warehouse management system, auto-guided vehicles, pulse moving line, 3 stations to operate all of this process, there were some very specific outcomes and metrics that came out of this process from a digital point of view. Number one is that all the way through receipt to stock, stock back out to issue, we created a process where no one had to touch a keyboard, no one had to call out a number, no one had to write it down or highlight. Everything was transmitted via a scan, a voice pick, or an API transmission from that standpoint. The pulse moving line tied into the auto-guided vehicles and moved equipment back and forth through this process. So to your point, Schaff, about outcomes, so what did this do for this largest army in the Marine Corps? It reduced labor hours by 32%. It increased speed or velocity of equipment to shelf by 37%. And we all know what that means. If something is sitting on the floor, moving through a process, you take the chance of it getting damaged, lost, even worst case pilferage, especially when you start talking about weapons and other highly, well, anyway, when you talk about that type of gear. Some other type of measurements also that we got through this is we reduced MHE by 83%. So you can imagine all the forklifts and pallet jacks moving equipment around. To take 83% of that movement out of this process and where stuff can be, or gear can be moved down a processing line was critical. So out of this, I'd like to say the biggest point out of that is a digital warehouse. From receipt on the dock, to storage, to inventory, back out to issue, shipping, and delivery. Again, everything through a headset, a scan, or an API moving gear through this process.
Thanks. Hey, Dale, John brought up additive manufacturing and actually referenced the previous panel. Talk about some, obviously, the great opportunities in smart logistics as relates to additive manufacturing, and maybe also some of the challenges. Can you explore that a little bit more?
Yeah, absolutely. I think additive has such great promise, and having been in the industry for a long time, it's like I'm excited about additive. And obviously, there's a lot of times we talk about the ability to produce those parts that maybe are smaller lots. I think the panel talked about that very effectively earlier. But and the ability to produce anywhere, even in theater. But I think the challenge that we see, and it was really well addressed, is some of the regulatory questions. How do you actually certify that and show those parts as airworthy? And so one of the things that we see, a couple of things, is how does digital transformation help with that? Digitalization, we're using machine learning in order to help speed up the development of allowables, using simulation. The other piece of it is just that airworthiness trail. It's one thing to be able to produce a part, but it's another thing to actually be able to then get it onto an airplane and show airworthiness. And so having that digital trail through the PLM system to be able to trace the data from that requirements, the design, all the way through how you produce that part, and then how it was installed and maintained on the aircraft, and to actually have that digital trail and be able to show that traceability is really where the power of the digitalization can help with additive and getting supporting these products in the field.
Thanks. Anybody want to disagree with what Dale just said? No? Or add?
I'll just add, when I was at DHS, the Coast Guard kind of is the beneficiary of a lot of old equipment that, they get Navy helicopters, they get a bunch of different stuff. So additive manufacturing for them is really an important thing. A lot of times they have stuff that was at end of life 10 to 15 years ago and can't, maintain them. So the airworthiness, and I also just add on the risks. It's something that we see in additive manufacturing, the specifications that you're talking about and the material, whether it's certified to spec, so you get a part and you got to kind of weigh that. So I think there's an area of maturity for that. I'd also say, and again, just maybe a little bit like with the Army and their OIB way that they're trying to kind of go through their modernization, if you walk the floors of some of these levels in the OIB, the depots, you'll notice like not very much at capacity. And you see very old buildings, old machines, and so you can see not only within the Air Force, but within the Army, significant amount, and they're looking at additive manufacturing as a way to also gainfully employ a capacity that needs to be in place. And so I see that as just a tremendous opportunity.
Thanks. John, did you have something else?
Yeah, and I'll add, building on the digital transformation of it, it's fun because PLM was really designed with a lot of traditional manufacturing in mind, but adopting those mindsets to additive manufacturing is opening up a lot of opportunities. So when you have that digital data, all that, you can do analysis on the, let's say, the OEM geometry and figure out AM candidates to figure out, hey, what can we use to enhance our supply chain? You can take BOM transformation information that we typically take engineering to manufacturing to start looking at additive manufacturing service level bill of materials. So then you can start identifying, hey, what components in a vehicle system can we start manufacturing closer to the source, closer to the objects, and then start focusing on those long lead items, not have to worry about the whole bill of material, that whole configuration management, but start focusing different things on different styles of manufacturing around, whether it's traditional, whether it's sourcing through DLA, or whether it's just producing it out on the field or producing at a depot. So using these traditional PLM mindsets really with additive manufacturing is kind of helping smart logistics kind of, get it more intellectual.
Thanks for that. So let's go to industrial Internet of Things for a second. Or maybe more in a few seconds. And I think we're going to hear more about this a little bit later as well. And specifically, Chad, you've got some experience in this. So let's talk about, and this is largely an industry team in here. What do we need to do to help the DoD be able to embrace industrial Internet of Things? Because obviously there are many challenges and obstacles. Security is obviously a huge one. But what things do we as industry in partnership with our DoD agencies need to do to help to enable industrial Internet of Things?
Oh, great point. I think there's a handful of topic areas that we can cover here. So some at the top of the list is number one is the infrastructure that was just talked about a few minutes ago within the DoD is, you drive down 75 or 85 interstate, and you see new Amazon buildings coming up every day. Every other mile, there's a new one coming up. We don't have that luxury. So in this first smart warehouse, when we started talking about data, IoT, how we address that, it's a 1950s warehouse where we're working in. And we had fire suppression, we had floor issues, we had power and utility issues we've got to work through. So I think the first thing is being able to address the sandbox of where they're playing in, is what our clients are playing in, being able to bring a practical solution to that application and making sure that it fits that overall scope. And it's not to say we sub-optimize at all, because we're installing autonomous vehicles all the way to utilizing the equipment that Shaf is pointing to. I think the second big thing, as you alluded to, is the cyber aspect of this, is that we know that our clients here, and again, the smart warehouse that we're working in right now, our end result is delivering that ATO, and that ATO is our final transition to the Marine Corps at the end of next calendar year in December of 2023. So working through that RMF package and all the way through this process is a critical aspect that maybe in some cases some of the commercial applications still have these same components they have to work through, but knowing that we have weapon systems in play creates a different vulnerability within this process. I think thirdly, it's around the data itself, is how do we take the data and less of the rear view mirror and more of the predictive side of the equation. How do we create those optimization engines to help start taking that control tower point of view into this process and enabling the leaders in these areas to be able to see and predict forward to what's taking place, where the need is going to be, all enabling that readiness calculation.
Thanks. Anybody else?
Yeah, I'll kind of add to this, add to that a little bit. I think one of the things that we we see a lot is just, there's so many brownfield, solutions out there. We don't have the luxury that we're just always building a new plant or a new system and that everything's greenfield. And so how do you implement it in existing facilities? To your point, 1950s era warehouses, and how do you modernize in an effective way that enables you to scale? Sometimes I think, some of the companies that I've focused or worked with, they'll kind of focus on one or two use cases, and they'll look at a solution for those use cases, not really thinking about the bigger picture. How will they scale that then to actually apply across that entire warehouse? And so I think that's very critical is, how do you actually roll it out? And so one of the things, we've seen, Siemens is we're a technology company from a digital industries and software and hardware, but we're also a manufacturing company. And so we've been through this transformation ourselves where we have started to bring IoT and MindSphere and our edge devices to these factories. So, we have manufacturing plants all over the world. We have a facility in Amberg that has become like an Industry 4.0 lighthouse in how they've automated and the success story of how they, through this optimization that they're able to get with IoT and improving their optimizing their production processes without increasing the space, they increase their throughput 13x. And they're managing now 80 plants around the world doing this. And so that's the scale. So you start out, you have to start in one place, but then how do you grow it out? And then I will just touch quickly on the cyber piece as well. As now you're managing this data and you have to protect it. It's in all different places around the world, and you have import-export restrictions everywhere, and you have to be able to manage that data in a way. So we're able to do that because we do so much work blending IT with OT. A big key element of that is that cyber piece, and you have to protect that data. So that's really what we're seeing. Okay.
Yeah, I think this room, industry, what can we do? I think we got to be careful. It's a candy store out there right now. Technology is way above where we're at, and I think, especially at IBM, we got to be careful to not over-recommend. I think I'm spending a lot of my time in the last probably 6 or 8 months showing people what's possible by using examples in commercial. But even if you were here a few minutes ago and seen that great presentation of a rocket manufacturing in a box, right? I mean, that is lifetimes ahead of a lot of the depots that are out there. It's great stuff, and it's good to enlighten. And the challenge that I would just say for us in this room is, a lot of times we're talking to the top of the organization and to all levels of operation. And the top see stuff like that, and they get very interested, and they want to go after it. As a previous CFO, I would also say that the previous discussion on funding becomes something as we need to live within the bounds of what is funded. A lot of these modernizations that are starting to go through for IoT and smart logistics are things that they're trying to also compete for really important other operational needs of the services. And a lot of times what they're trying to do within the services is repurpose portions of O&M monies to try to figure out ways through it. The last thing I would say is that readiness, a big part of what IBM Consulting just focused on is they want to get there, the people are going there, but they haven't sat back and really put it in perspective in a process of like, well, what am I really trying to achieve? What are my priorities? How are my processes? How are my people? Am I ready to actually take on this? So, in our process, we do a garage process at the very beginning to try to get things organized. And so it's not ready, shoot, aim. And I think that right now, a lot of the stuff that we're doing is in the preparatory stage of really just trying to make sure that the client base is ready to kind of go after this and stay focused on what their priority is. Don't buy above what you need out there.
Okay, thanks. John, you want to take a swing?
Yeah, I'll just add one last thing. I agree with everything, but as IoT...
Oh, we got to have some disagreements. One of you guys has finally got to say, I disagree.
It's a great panel. But IoT
smart,
gives us it's a unique view that we're actually connecting ground level operations to leadership decisions. You can see those things real time. So as we adopt it, don't just kind of see IoT as great data aggregation, great visualization, but you can actually see it's closing that feedback loop between leadership decisions and ground operation ripple effect of those decisions. Let's find ways together with industry and government to find out how can we really, from that feedback loop, start making better decisions. Let's not make the same decision over. We're getting real-time feedback. Let's use that to inform future decisions and get more efficient and more productive with each each change.
Okay, so several of you now have used the D word, data. And we've even talked about data as a weapon. Well, isn't part of the problem here is that as we increasingly enable industrial IoT or just IoT in general, we now have too much data? We're overwhelmed by data. How do we manage? What's the data governance things we need to be thinking about and planning for? Go ahead, you're ready.
Oh. Thank you. Thanks, Shaw. I'm going to use some practical examples around the data application side of this because I guess there's a debate on, is it too much data? How do we use it? What do we do with it? So when we think about optimization and optimization engines and the analytics associated with this, where 5G and other components come into utilizing the data itself is being able to now take this to the next level of actually optimizing or creating the engines behind using that data. So for example, when I mentioned the smart warehouse a few minutes ago and we're moving robots around, if you think about it in the morning, a robot gets tasked to move 10 pallets of gear around a warehouse from receipt to storage back to issue out to shipping and delivery. We want that robot to not only take and move from spot to spot, but we want to create the efficiency behind that's doing. So we're looking at the data itself, how it's tasked from the WMS, and informing the robot through an engine that says, here is the most efficient path to go do this. We don't want it to go up and down the same path each time to go to different spots within the equation. We want to form that most efficient route to move through that process. So that data becomes very critical in performing that analysis. The second thing is we think about storage of gear in a warehouse, and you think about the shelving space and the cubic space of utilizing a shelf. And most times when we measure, if I were to ask questions, we'd probably get a variety of answers to it, but I would say it's probably, through our measurements, somewhere in the high 50s, maybe low 60% of shelf cube space optimization. So how do we take that data now and build that heat map of a storage facility? Also understand the slotting analysis that goes along with that, ABC, where it's stored at, the fast mover versus slow movers, and how do we take that data and cube it into that space to make sure we're utilizing 90% greater of that space. So that data itself becomes a critical factor in this process and in how the optimization of that process works. So I guess to your point or to your question about is there too much data, how do we utilize it, how do we store it, I think the criticality is how do we think about how do we utilize that and enable the people in this room to be able to do more with that data and that process.
Thanks.
I think it's, data, we talked about it yesterday a lot, and I liked the analogies of, data's the new oil. It's like somebody called it data, it's like soil. And I was like, you think about soil, and if you're looking for gold, you scoop out this big scoop of stuff, and then you have to refine it or sort it out and finally get gold. And so you get a lot of soil and you get a little bit of gold. And I guess being next to the gold mine out in Mojave, kind of watched that in action a few times. But so do we have too much data? Probably. How do we know? That's a great question. And so this is where I think when we think about, like the digital twin, you can do data analytics, and you need to have data analytics. You need to be able to do that data mining to find insights that you're not going to find otherwise. But you also need the context. And so what we see a lot is how do you use the digital twin, your understanding of the system, or sometimes we don't talk enough about it, the business digital twin, like the digital twin of your processes, your business processes. How are you moving parts around the country, or how are you moving material flows? And so being able to understand that's what can really start to give context around those data insights that you're starting to get. And so that's what a lot of our customers are seeing, is that they're collecting all this data. Taking data off of airplanes for years, there's no shortage of data. It's what to do with it. And so that's where a lot of times the digital twin can really come into play there. So you can start to sort that out and to find those correlations of interest so that you can start to focus on those areas and put the right sensors on the system of interest. If it's a warehouse, it's an airplane, it doesn't matter. You're trying to understand how to make it operate better for you to have better outcomes.
Yeah, the weapon kind of analogy, pretty aggressive there, Schaff. But I think, you think about it, if you were an operator to try and get out there and get a support, I mean, it really is a weapon. The data enables better throughput if used and if analyzed correctly. You're able to get the most out of getting, we have these surges, Ukraine, all these things that happen in real time are taking wear and tear on equipment, and we have to get things back into depots and get things maintained. And so very important. But I'd also say that on the aggressive side, it can also be used as a weapon against us in the United States. And I think that, when we talk about data at the machine level, and really us being able to predict when the parts are going to be needed, what parts, when do I shut that machine down, how are things operating, what's in that machine, are the parts and the subparts of supply chain risk management, being able to see and analyze the entire supply chain. And I think you had talked about control tower and the kind of compare that with supply chain risk management is, look at the F-35. There was parts in there actually collecting data that was doing something that we shouldn't be doing. And then you also have other examples in the industry where like the data gets used, manipulated to potentially shut down. And so I do a lot of work in the infrastructure industry. So like dams and infrastructure, the way they shut those things down is they inject data that shuts off control systems in these types of operations. And so we have to protect against that and the encryption of that. So I think as we go through this process together, especially with the Air Force, I think we also need to make sure that we realize the data is a weapon. It can be used against us, and it could be a great enabler too.
And I'm going to kind of take it from a practical architect perspective, but understand your capability and your storage of that data. Manage your thresholds as it's coming in and understand really how much data you can handle. Big data is a real thing. Data overload's a real thing. It's all about making sure that you're getting good information out of that. Good information from a smaller data set is better than bad information from a larger data set. So over time, you can invest in technology and data science and things like that to expand your bandwidth. But for right now, understand where your bandwidth is. Speaking as an architect, getting that from leadership, it's always the biggest conversation we have is, hey, sure, we could collect all of it, but with all that, how much are we going to be able to really do with it? So it's about really just understanding what you can handle and running with it, and then investing in growing it, and then getting that larger data set, that number crunching done.
Thanks for that. Let's talk to people. This time when we answer, we're going to let John go first so that he doesn't feel like he's always repeating everything that you've said by the time it gets down to him. In our depots, in our manufacturing, we have entire ecosystems of humans, biological things. How does smart logistics either enable, make obsolete? What things do we have to think about in terms of how we use human in the loop when we implement smart logistics? And John, we'll start with you.
Great one to start with me on. I guess I can say kind of as I spoke to earlier, with these sensors kind of being there and everything, you're getting real life feedback from down there. So you can see from how it's affecting the humans on the ground workers, everything there. You can see the decisions that leadership's making, all that, how it's directly affecting them. So not only take the data coming in, but listen to the people. Human capital is a real thing. It's just as important as the latest technology. So find ways to not only communicate and get information from them, but their feedback tied with what you're seeing in data, make decisions based on that. That's the best I got.
Yeah, I think the data from a perspective of the human in the loop is that we're really careful at IBM to talk about augmented intelligence, not artificial, and making sure that the human in the loop is the important part of that. I think something that we see is that a lot of the operations, the people that are able to utilize this type of capability, it actually upgrades their skills. They end up having a need to upskill to be able to become almost data scientists and operators and everything all in one. Job satisfaction, we see this in the commercial side, job satisfaction goes up. And something that I think is really real, not only in DoD but across federal, is this type of skill set based on STEM, working its way through college, et cetera, there's not enough workers. So it's not like we're taking jobs away from industry. It's, there's a lot of competition for this type of skill, and we need to kind of help the services, including the Air Force, get better at using what they got. And even if they can hire a much higher level, they can't really find the resources. So I think in the end, this data strategy and this way to use, especially in industrial IoT, will make it more affordable in the operations, make for a happier employee, somebody that really feels a sense of what they're doing is really important, and that their skill set has been up, and they'll be able to hit industry better.
Thanks.
Yeah, I think it's, we often look at this and we see the technology, and it's easy to get wowed by the technology, but it is about people and processes. And you start changing their processes, and the people are affected by it. So they have to buy into those changes and what's happening. And I think about how things are changing in our environment. And the question this morning, to General Morris about, are we, what do we need to change? And we're changing the processes. If we want to switch, we have to change how we do business, and that's hard for people because they have 30 years invested in how they did something. And but I think really how I think about it with the people, we can't fill all the positions that we have open. I've been asked several times, like, well, we do all this, and you keep talking about these productivity gains, and I'm not going to go tell people I'm going to lay them off. I'm like, sorry, but you can't hire enough people today. You're filling the gap with technology and process changes. And so like when Chad talks about how much they reduce the amount of travel, inside of a warehouse, that's less people that's moving stuff around. When we talk about the work that we've done with the Navy at their shipyards, as they are upgrading and modernizing their shipyards and going to digital shipyards, where they're moving things hundreds of feet instead of miles, that's someone that's not driving a forklift around. And so that, I think we have to be mindful that we're changing how people work. We're upskilling them, and it does offer them new opportunities, but they have to see the benefit. Like, why is my life going to be better, because of this, this technology? And I think when we can address that, we can be very successful in how we roll out these new solutions.
Okay, thanks.
Yep. A couple things. One, I think every position description that you have now that you're updating or you're addressing to your workforce should have some aspect of digital or something in that position description. You need to plan to start hiring for the next group of people that are coming in. They have to have that flavor of that capability. It doesn't have to be over-the-top program or anything like that, but be comfortable with the technology. Secondly, what we've learned is that I think you need to address the government civilians, the contractors, and the airmen and women slightly different in how you approach the training aspect of this business. We have just found that we have to go differently at that process. The contractors have their work scope that they perform, and asking them to blend outside of those curves creates a little bit of a, well, you can imagine what it creates. The airmen and women, or the young lance corporals and so forth, they get it like that. They're on it, the technology and so forth. They're the most adaptable to this process. And we've seen it over, at least in my business, we've seen it over and over again. I think the third thing is the training itself. The old standard SOPs and desktop manuals and paper copies sitting on their desk are just not as effective as they used to be. We've developed or tried to develop training that is simulation-based, that is practical application, that is in small bites of increments at 45 minutes to an hour at a time on a specific application, and how we approach this with these, whether it's on the flight line all the way back into a warehouse, of how that operation works. And then finally, to me, it's seeing the big picture. Taking those small, components of this is almost like digging a hole in water. The personnel just didn't see what's surrounding them on the input and output side of the equation. So taking that broader view of what we're trying to accomplish, when we talk about reducing forklift travel or MHE demand by 83%, it wasn't about trying to reduce headcount. Yes, we did reduce headcount by 32%. We created capacity to do more work. We moved those into positions that were open in other areas. And by the way, moved one weapon warehouse into another weapon house and used that warehouse from the component of not having the Milcon type of work that was needed. So anyway, those are some of the components we see from a personnel or human capital aspect.
Thanks. So now we're going to have a little fun. And I didn't tell you I was going to do this. You're going to get to think on your feet a little bit. What I want us to get to is what are the top 4 challenges to implementing smart logistics or IoT, and go wherever you want to. So we're going to get to the top 4, but you only each get to give me one, and you cannot repeat the one from somebody else. And so we're going to just do this randomly. So whoever's going to end up being number 4 is going to have to be really smart. So we're going to start with Troy. You get what's one of the top challenges?
What are you saying, Shop? Jesus. Anybody gets on Shop's panel next year, be ready.
It's a softball.
Yeah. For us, and I kind of said it earlier, is the readiness. I think really trying to make sure that you have a roadmap to the future. Don't get fixed on the thing that you want to buy that's going to be unbelievably good and it'll do a lot of stuff. Think about what is the process, of being able to assess where you're at, what is your objectives, do you have the right personnel, and do you have a kind of we're a technology company too, but it's an agile process to be able to fail fast and have the culture to be able to accept that. And, in manufacturing, like in Toyota, they had a thing called Kaizen, and before we would do a major supply chain or a plant redo, we would work in that plant for a year to get ready. We would make sure that, we went through the people, the process, the systems. We looked at the culture. We looked at the policies. We looked at corporate. We looked at different plants. And then we tried to move forward. And we tried to focus on a prototype and then start to build that thing across and fail. And then build it and fail and go as fast as we could once we got to I think a lot of it is just having a strategy and a process. And, we call that the IBM garage.
Okay, thanks. All right, so that's number 1 is readiness. They're all starting to sweat up here now. Okay, John, you're next. You get to give us the next one.
Sorry, I'm going to take the easy one. Cybersecurity. With all the sensors and everything, especially in zero trust networks for the DoD, you really got to look at how sensors by default cannot really exist in a zero trust. They need to be authenticated coming in. So it's trying to figure out, all right, how can we approve these devices from sending in data in a zero trust network to enable true IoT in a DoD landscape. So really look at that, really look at kind of ways that you can analyze behavior instead of, explicit approval, that type of stuff to make sure that these sensors coming in are not compromised, that the data is good, and that you're not introducing cyber risk by introducing an IoT environment.
Good, thanks for that. All right.
Sorry, guys.
That's good. Dale, you get to give us the third one. Chadstein, Schaffner.
Let's see, should we collaborate? I don't know, when you first asked that question, I think the thing I thought about was, the phrase that came to my mind was where to start. Our processes are, some of our processes, our plants, our warehouses, they're 50 years old. Some of the platforms we're maintaining are 50 years old, and the company that, we talked about this already, the company that built it doesn't even exist anymore. And there certainly isn't any digital data. And so you start reverse engineering stuff. I worked in Wichita for many years. I used to hire engineers from Boeing, and they were 27 years old working on B-52s, and they'd tell me about the treasure hunts they would go on to try to find information when they needed to update the B-52. The airplane was 30 years older than they were. So anyway, it's where to start. And I think that's, in having a plan, putting together a strategy of how to actually work through it. And as I mentioned earlier, that it's too easy. Sometimes people look at, well, we're going to start with a use case and we're going to try to solve that use case, not realizing that they kind of painted themselves into a corner. So, that's where, I think if you have somebody that you can work with, or that you can look to other industries sometimes on how they've solved some of these problems, where we, in our case, we partnered with a lot of companies that have been through it before as well. And so, there are companies that have gone through it. And so when you look at like the DoD, somebody made a comment earlier that they're maybe a little bit behind the industry in some respects. Some respects they're ahead. So I think that's having a partner on how to proceed through it.
Okay, all right, we're almost out of time, but you still get you still have to answer that.
I think if we think about the title, Smart Logistics, and we look at the bill of material, what we typically are deploying and the type of technology and processes and equipment, I think what would most land on is that all of this has been built in the cloud. Most of the infrastructure, the solution set, the capabilities, even the O&M side, the updates comes from the cloud. So when we think about Air Force, when we think about the federal government in nature, we have to typically build this out into an on-prem process or a disconnected system first, which means we sometimes have to back up a bit. We have to go from the cloud, come to an on-prem environment. We're talking about virtual machines or VMs to work into that effort to go through that process. And to a little bit of what was led off with is, how do we then take that back into the cloud once we achieve the ATO and we're able to access the network? So I would say one of the hardest problems right now is taking systems or solutions that want to be cloud enabled, that want to be able to take place in a condition-based maintenance type format where you're monitoring movement of everything that's taken place and being able to predict when certain things are going to fail and disconnect that from the environment initially until you get this implemented and then work into that process. What we typically find is that we want to be able to enable that initially, go through that, because that's just the way the solution was defined. So it creates one step or one hurdle in going through that process.
Well, thank you very much. I also want to pass on my own thanks to this team: Chad Jones with KPMG, Dale Tutt of Siemens, Troy Edgar with IBM, and John Villegas with Sable Systems. Thank you very much for being here. Give a good round of applause for my panel, please.
Thank you.